Hey everyone, today we're going to do an example with a geometric series where we have three numbers, namely a, b, and c, in a way that their sum is 35, right? So together as a geometric series, the sum of their three terms is 35, and also their product, a times b times c, is 1,000. And so we're going to find a, b, and c. So the first thing we do is notice that since they form a geometric series, that these must be three consecutive terms, right? And since they're a geometric series, they must be related in geometric fashion. And so we don't know which one is smaller, which one is bigger, but let's say that the geometric sequence looks something like A and then B and then C, okay? In the form of like our first term, our second term, and our third term, okay? Very generally speaking. So since they're related in a geometric fashion, then we can say that B is A times their common ratio, right? Since they're part of a geometric series, they must have a common ratio. And then since C is next along the way, then we can say that C is B times R, which means that C is also A times R squared, right? Since C would be two terms down from the A term, then C is A times R again, being A times R squared, okay? And so now we can set up a system of equations. And so we have two equations. We can relate all three of these terms, A, B, and C, by A and by their common ratio, R. That's really important. We have two equations, so it's important that we can use relationships to get those two equations written in terms of only two unknowns, right? A, B, and C are too many unknowns to solve for with only two equations. But if we can relate A, B, and C together by only using A and R, that's two unknowns with two equations, we'll be able to solve for those, okay? So, if B is A times R, and then C is A times R squared, and of course A is just itself, then we can write that first equation. Let me call that equation 1. Let me call this equation 2 for easy referencing later on. Using equation 1, A will remain as it is, and then we'll write B as A times R. So again, the B becomes A times R, and we'll write C as A times R squared. Okay, so C times R squared, and that is equal to 35. Okay. Now, of course, we can simplify this. So sorry. That's A times R squared, not C, right? C is A times R squared. My apologies. So now we have A plus A times R plus A times R squared, and so you'll notice that A is common to every term, and so we can factor it out. We have A times 1 plus R squared is equal to 35, okay? Again, let's call this equation 1. Now, from our equation 2, this one, A, again, let me use a different color for this one. So, using our equation 2, let's let A remain as it was. Again, we'll write B as A times R, and times C, C again being written as A times R squared. And now, all of that is equal to 1,000, okay? So, now we have A times R times A times R squared. A times A is A cubed, times R squared is times R cubed, is equal to 1,000, right? And now, using your exponent laws, we can write the left-hand side, A cubed times R cubed, we can write that as A times R all cubed is equal to 1,000, okay? And now, it would be nice to have A times R by itself. So, to cancel out the cube, we can take the cube root sides, cube root of both sides, to be algebraically sound, and the cube root cancels out the cube, and so we have a times r is equal to the cube root of 1,000, and that is 10. So now we have a times r is equal to 10, and now we have another equation. Again, we have two independent equations, and we have only two unknowns, a and r, right? So this is a great example to use substitution or elimination, but this is definitely more suitable for substitution. So it's up to us which one we want to isolate to substitute into our other equation. I'm not exactly sure which one would be simpler to deal with. I think I'd like to get a isolated so that we can substitute it into this place, because there's only one a in this equation, rather than if we isolate r, we'll have to substitute it in twice, probably just a bit more work. So let's get a all by itself. So if we divide both sides by r, then these r's cancel out, and we get a is equal to 10 over r, okay? Now, we will substitute that into equation 1, okay? So, a is going to become 10 over r, so we'll have 10 over r. Here, before we do that, I'm just going to make a note. We're going to sub a is equal to 10 over r into equation 1, right? Just to keep things organized. So now we'll replace the a with 10 over r. So 10 over r times 1 plus r squared is equal to 35. Okay. And now, first thing we could do, there's an r in the denominator here. We probably don't want that there. So let's just multiply both sides by r. Multiply by r. That'll cancel out the r in the denominator, right? That's a great deal. And we remember to do the same thing to both sides. So now we have 10 times 1 plus r squared is equal to 35r, right? Now let's multiply through. So 10 times each part means 10 plus 10r plus 10r squared is equal to 35r. Okay. This is a quadratic equation, so let's get everything on the same side. Let's subtract 35r from both sides. And so then we have 10 minus 10r, minus 35r, right? Combining our like terms, the r's and the r's, 10r minus 35r is minus 25r plus 10r squared is equal to 0. Okay? And now again, this is a quadratic equation. To make our life a bit easier, we can divide everything by 5, right? And so if we divide both sides by 5, 0 divided by 5 is still 0, conveniently enough. And so we'll have 10 divided by 5, that is, I'm going to reorganize it to have r squared first. So 10r squared divided by 5 is 2r squared minus 25r divided by 5 is 5r, and then 10 divided by 5 is plus 2 is equal to 0. Okay, and now we can use decomposition. So what two numbers multiply to make 2 times 2 is 4, so multiply to make 4, add to make negative 5. Feel free to take a second and think about it. Those numbers are going to be negative 4 and negative 1, right? Negative 4 times negative 1 will be positive 4. Negative 4 plus negative 1 will be negative 5, right? What two numbers multiply to make positive 4 and add to make negative 5. That'll be negative 1, negative 4, negative 1, negative 4. And so now we use decomposition. So 2r squared minus 1r, so minus r, minus 4r plus 2 is equal to 0, right? factor the first two terms and then factor the last two terms. In the first two, we can factor out an r, so we have r times 2r minus 1. And from the last two terms, we can factor minus 2. So we have r, again, 2r minus 1 being 0. Now we have the same expression inside both brackets, which is a good sign. And so we can factor completely as r minus 2 times 2r minus 1 being equal to 0, right? And that provides us with two solutions. This factor, if r minus 2 is equal to 0, and we get r is equal to 2. If 2r minus 1 is equal to 0, then we get r is 1/2. And so it looks like both solutions are applicable. So let's address those. So let's bring it back. I do not have much room left. Let's bring these over here. So A is 10 over r, right? Let's break it off into cases. If r is equal to 2, and if r is equal to 1/2. If r is equal to 2, then A is equal to 10 over r, right? We have an expression for A in terms of r. A is 10 divided by r. So if we're going to go with the r is equal to 2 value, then A is going to be 10 divided by 2, which means that A will be 5. And if A is 5 and r is 2, we know that B is A times r. So B will be 5 times 2, which is 10. So B is equal to 10. And finally, C is A times r squared. So that's 5 times 2 squared. And that means C is 20. Let's analyze this first solution for a second. Does this solve both equations 1 and equation 2? Well, A plus B plus C should be equal to 35. Let's check that. A plus B plus C is 5 plus 10 plus 20, which is 35. Equation 1 holds. Equation 2, A times B times C equals 1,000. 5 times 10 is 50, times 20 is indeed 1,000. And so this solution for sure works. The other solution is if r is equal to 1/2, right? So again, we have an expression for A in terms of r. So if r is 1/2, then that means, excuse me, A is equal to 10 divided by 1/2. And 10 divided by 1/2 is 20, right? Now again, we know that B is A times r, so B will be 20 times r 1/2. So B will be 10. And finally, we know that C is A times r squared. And so C will be 20 times 1/2 squared. And that is equal to 5, right? 20 times 1/4 is, of course, equal to 5. And you might notice that these are the three values in reverse order that we found the first time around. So again, equation 1, A plus B plus C equals 35, 20 plus 10 plus 5 solves equation 1, and 20 times 10 is 200, times 5 is 1,000, and so equation 2 holds as well. And so both solutions are valid, and so we have either r is equal to 2 and A, B, C are 5, 10, 20, or r is equal to 1/2, in which case we switch the order. A is 20, B is 10, and C is 5. That was a great problem. So thanks for watching. If you guys have any other questions or comments or other problems in this section you'd like to see done out, please leave a comment below. Thanks for watching.